Welcome to Coffee Cocktails. In spite of everything, I am still Al. For a long time now, years, I've wanted to learn how to design circuit boards, or PCBs, and every time I tried, I would bounce off it a bit. I would find it too difficult or the software too obscure. But a couple months ago, I gave it one more shot, and this time it seems to have stuck. I've mostly been making some things for my synthesizers and small little things like that, but I've noticed that when I'm trying to test out parts on a breadboard, it can be a little bit difficult. One time I was holding down like a thing and another thing and a power cable in a breadboard, and I was trying to plug in a fourth thing, and I'm like, wait a minute, there's got to be a better way of doing this. And I looked it up and I didn't see the thing I imagined, so I built it. This is a little prototyping breadboard that fits right onto a full-size breadboard, and it gives you a lot of cool little neat things, so you don't have to have 6 different hands to work with it. Since it's shaped like a C and it goes on a breadboard, I've decided to call it the Croissant. Close up. If we take a look at the standard Croissant, we can see a couple things right away. The Croissant is a multi-purpose PCB. So a lot of things are going to look really weird and cramped because we're not supposed to use all these footprints at once. We get to select what we do. The primary purpose of the Croissant is to take a power connector and put it into the top and bottom power rails of a breadboard, like this. We have a breadboard, the size and shape. We'll get to that in a moment. And just along the top and bottom rails, if you're not familiar with a breadboard, these top sets of holes and the one below that, as long as these 2 bottom sets of holes, these are all connected together in straight horizontal lines. So if we clip something in that has power running into it, ta-da! We now have that same power going across the entire rail without having to hold on to anything. It's great. The unit takes power in from a power connector that we solder on. This is a power connector that goes to a pocket rack format synthesizer, which is just made by Teenage Engineering. The much more common Eurorack format plug also fits in here. It is a footprint that also fits more than one thing. Now, to step back a bit, if you don't know what a circuit board is, it's actually quite an apt metaphor for a croissant. It is laminated in layers. So this inner core is just some sort of filler, usually fiberglass or shredded paper that's squished together with epoxy. And then on top of that, you have a layer of copper. And then usually you have a second layer of copper under that to make a sandwich. And then that copper, as we can actually see through this purple pattern here, is either laser etched or chemically etched or removed in some way to where you have copper going from one part of your board to another, thereby completing an electrical circuit, once you add the electricity, of course. On top of that, then we have a solder mask. That's this nice purple coating that doesn't conduct electricity, although it comes in a lot of other colors like green. And then after the solder mask is applied, there's usually parts that are left either bare copper or in this case with a nice silvery looking finish. These are conductive pads. So if you want to say take a piece of electrical component and solder that on, you now have a conductive surface to do so. The idea is that we're just trying to connect parts of this board, one part to another, so electricity can flow between them. Now the basic use of the Croissant is that if you just want power to go through these pins out to your circuit board, you can do so pretty easily. There's extra features, but if you just want to get power flowing, all you need to do is solder on a Eurorack or pocket rack power cord in the right orientation, and then you'll need to either solder in this switch right here, these little 6 pins in the middle, And then you'll need to flip it over and you'll see this interesting thing right here. You can ignore these yellow wires. That's an error that I corrected. The newest version doesn't need this, this fix. You'll see here that there are these two little pads that are labeled as 0 ohm bypass. This is what they look like when they don't have anything soldered in. If you connect these either with a 0 ohm resistor, as I've done here, or just a big old blob of solder, or I don't know, a piece of wire or something, then whatever you have going into this power connector will flow out of these pins into the breadboard, which is an easy option. But if you solder this in upside down or backwards, or your synthesizer has the plus 12 volts and the negative 12 volts reversed for whatever reason, then that's just going to flow straight out into the breadboard. So this Croissant also has a neat little power protection feature. So if you don't solder in the bypass, you'll still need to solder in the switch and the plug. There's a few extra components that you can solder. A polarized capacitor, a few unpolarized capacitors, there they are, another polarized capacitor, and some diodes, which I don't have yet, so they're missing here. But if you pretend they're there, then this will have what's called reverse polarity protection. So if you, for whatever reason, have plus 12 volts going where the minus 12 volts should be, like if you plug this in incorrectly or solder it in the wrong way around, it will make it so that no matter what way this plug is facing, you'll have 12 volts going to this top line, ground going to the middle two lines, and negative 12 volts going to the bottom line. It will protect you from reverse polarity. And then there's a lot of extra features too. There is a 5 volt linear regulator right here. And there is a 3.3 volt linear regulator right here. If you install their associated capacitors as well, you will get these nice little 3.3 volt and 5 volt lines. That's why it's not just these two pins right here. You have these 5 pin headers each that go to the main part of the breadboard. So right away, you got more power options. You have 3 volts flowing into, 3.3 volts rather, flowing into these lines, 5 volts flowing into these lines, so then you got even more power to connect stuff with. Also, the middle part of the Croissant, this is a universal footprint that can fit either a vertical headphone jack, a horizontal headphone jack, or a potentiometer. And no matter which one you solder in, it will allow that signal from each of those components to go to these 3 rows of pins, columns of pins right here. Also, these columns of pins right here, this will mirror the same output. It's all connected. And you have 2 of those, one for the top and one for the bottom. So if you have a Croissant on the side over here and you have a spare you want, or you just want something else, you can additionally solder in these 5 pin headers and just get a little bit extra usage. Now with one little board, I could have 4 headphone jacks, or 2 headphone jacks, and the horizontal headphone jack and a potentiometer. It's a great way of just putting things on a breadboard that aren't generally meant to be there. Also, it's got a nice little power LED. It has a few other really neat features. And one thing with ordering a circuit board online is that you make the file on your own and send it off to a company. They print it out somehow, I imagine on a very large printer of some kind, and mail it to you in a couple days. They generally charge by surface area, by the actual length times the width of your board that you ask for. So the first board I ordered was just the C shape, but then I realized, hey, if I put something in this middle area right here that I can snap off later, that's free. So this is a design for an audio amplifier using a chip. I forget the name of it. I'll put it in here. It costs like 2 cents, and it can amplify audio signals. We'll get to the exact details of that in a little bit, but if you want to keep that in, you can. If you want to pop it out, you can do so. I was trying to make it so you can pop it out just with your hands, but you would actually need to take a knife and score these little mouse bite vias, and then just warp it out from there, just flex it out. And yeah, that is the Croissant. Let's get into a soldering example. Let's say you've managed to acquire a Croissant PCB and you want to go ahead and use it. Well, let's go ahead and start that process. The first component you will need is a power connector. This one supports the 5x4 Eurorack power connector, or my preferred model, the 3x1 pocket rack connector, which will have in this pin right here, negative 12 volts, then a ground connection, then positive 12 volts. The middle 6 pins here on Eurorack are all ground, and then we have plus 12 and minus 12 on the sides. I just like that this is a little bit compact. So that's going to slot right there. Now, whatever orientation you put this in its most basic configuration, that's where the power will go. So make sure it's in correctly if you want the labels 12 volts and minus 12 volts and ground to be all correct. And one thing that really improved my soldering skills is I use flux on just everything. I thought it was optional before, but really isn't. So I just have this nice little no clean flux pen, and I'm just going to smear that on the pad that I want to solder here. Let me get my tiny little reel of solder. And normally I don't solder while holding in the air like this. Well, who am I kidding? I absolutely do. But I do want to make sure that this is clearly visible. So to solder a through hole component like this, where the pin goes through the board rather than sitting on top of it, it helps to tack one pin into place first, and then you don't need to be holding it at such a weird angle. So soldering is generally a process both in plumbing and in electronics where you don't want to put solder on this joint. You want to let solder flow into the joint. So I'm going to put my hot soldering iron right there on this pin and pad to heat them both up. I'm going to feed the solder into the pad. Once I get the first one done, it'll be much easier. And I have a fan, a filter fan going right over the side here. Lift off the fan and it's already solidified. Now that's a pretty good connection. So now I can finally set this down and solder the other ones. So again, just put the soldering iron on the pad and the pin and feed the solder into it. This is lead-free solder, so it's not quite as easy as leaded solder, but I don't want to deal with lead. Get my fan a little closer. There we go. Pad number 2 of 3. And then we're going to go back and do the first one again. There we go. Now, what we'll need to do is make something to bridge the switch. If you want, you could just put wire here to connect this switch. I actually have these switches though, so I'm gonna go ahead and do that. With components like this, it is a little tough to hold them in place. You know, you have to hold them with one hand while they might be wiggling. So here's a trick. If you have blue poster tack, I don't want to melt that on the soldering iron. Removable mounting putty, as it is, I guess, called here. You just take a glob of that, work it a little bit, and just glob your part into place. Good. Now that's going to hold it for you while you do the soldering. Careful not to melt the putty. There we go. Switch in, putty off. That's pretty nice. Now, if you want to just use this as is without any of the power protection circuitry, these two pads are the ones you're going to want to bridge here. In a future design, I might want to replace these with actual solder jumpers to make it easier. But if you have 0 ohm resistors or a piece of wire or an especially big blob of solder, just by connecting these two little silver pads and these two little silver pads, that's all you need for a basic croissant. One normal, plain butter croissant. However, if you do want the reverse polarity protection, then we'll need to add a few other components. That's where you add the polarized capacitor, the diode. Basically, you just don't jump this bypass and then you populate everything else. The next thing that we need to do is we need to go ahead and install the header pins, and there's a trick I have for this. If you want your header pins to be installed in the same exact spacing and being held at the same height and width and all that as a breadboard, you get a breadboard and do your soldering there. Let me show you. So first we're going to cut the needed pieces. The color doesn't matter, I just happen to have this nice blue. I'm going to cut 1, 2, 3, 4, 5 pins for the top. 1, 2, 3, 4, 5 pins for the bottom. And these are double pins. You could just use 2 pins of the single rows, but I have this, so I'm going to cut it. I'm going to get a row of 2 of these pins. That flew literally outside. I'm going to try to do another one that doesn't fly outside. Ah, found it. I had to fight a squirrel for it, but it's back mine now. Sorry. If it helps, the squirrel deserved it. So we're going to put some flux on these pads. Even if you don't install the headphone jack or the potentiometer components, having these rows of 5 help just keep it in place a little bit better. I'm going to install this upside down so it's just a little bit better for camera. All right, nothing's holding these in place. We could use the poster tack trick, but I'm just going to put these first 2 headers in. Actually, just going to flip it over. There we go. I'm going to put these second headers in. Make sure that's nice and flat. And then I'm going to squish this into the breadboard. Well, I'm going to, if I flip it over, I'm going to ruin everything. So I'm going to go ahead and install it upside down like this. Yeah. There we go. All right. Now that's not perfectly aligned. That can definitely move. So as long as I hold this down as I solder 2 pins, that will be all we need. Or actually, you know what? I'm going to use my friend Blue Tack. Just going to press down. There we go. Nice. Now I only need to really hold with one soldering iron. So I'm going to solder this corner first. I'm going to solder this corner second. And I'm going to yeah, actually that's pretty fine. So I'm just going to do the rest of these then. Now one thing you'll notice if you've been soldering a lot, sometimes a pin can be really hard to solder for no good reason. It'll feel like your iron is just not heating up enough. I always remember then that's a ground plane, which these two are. So what you can have here on a circuit board is you can have traces, as they're called. You can have these little bits of copper going from one part to another. You see this is a thin one. This is a thicker one. What about this whole area right here? That's one big trace, and that's for the ground plane, sort of the return path for all the electricity. It's a very good conductor of electricity and also a very good conductor of heat. So if I put my soldering iron here, it's going to suck a lot of that heat up and cool it down way fast. Like this looks like my soldering iron is set 100 degrees Celsius less than it is, but no, that's just because it's a ground plane. You can get it if you just keep trying at it though and just spread the solder out nice and evenly. Make sure you preheat the pad. You do want to make sure the pad is also hot, otherwise the solder won't really stick to it. Now if you want to unsolder or do any rework later, yeah, a ground pad like that's going to be harder. Also note that in addition to the 5-volt line right here, we have this one that's labeled as X. That's just nothing. There's nothing going to it. I just wanted to keep that there as a spacer and to keep it nice and attached to the breadboard. So I'm going to solder the remainder of these. I have 3D printed this cool little solder dispensing pen. It doesn't quite fit the little solder roll that I have though, so it's not excellent, but when I have it set up, you can just roll these little wheels right here and the solder extrudes out the end here. But for a small job like this, I can just poke it in with my hands like this. If your soldering iron seems to not want to work anymore, odds are it's dirty. So just clean it off a little bit with your solder cleaner. There we go. Make sure not to touch anything plastic with this hot soldering iron. You'll melt it pretty quickly. Don't forget these 2 ground connections there. And there you have it, a perfectly good Croissant breadboard. Important announcement. The internal pins of a breadboard are all a standardized size or pitch. However, the external power rails can be one of several different sizes. Check the design files in the description below to make sure you're getting a Croissant prototyping breadboard with the right pitch. If you don't, I'll find you. The next thing that we can do is we can do some soldering for these guys right here, the additional power pads. Consult the documentation to tell which is which. You don't want to have 3.3 volts going to your 5-volt line. Otherwise, it's just mislabeled. But I'll show you how to do surface soldering on these. I have consulted the manual and figured out which one is which. The one on your left here is going to be the 3.3 volt, and this is the 5 volt. Interesting thing about this footprint right here, this is designed to fit either a surface mount linear regulator, little guy right here, or it can also fit the much larger through hole one that kind of like pokes through and stands upright like that. Don't do that with these. So these are pretty easy to solder. I'll just do one for now. Once again, use our friend flux here and just draw that flux on the pads. And the way I like to do surface mount soldering is I like to pick one pad. This big one actually might be a little challenging, but these have holes in them. I'll go with the big one. And with nothing on it, we're just going to put a little solder on the pad. Right, we need to get it a little hot though, so let's make sure we're doing that. Okay, just get a fair amount on there. Good, good. We've tinned that pad. Now we're going to take our component, line it up, and we're just going to reheat or reflow this solder. So let me get this in a nice plot. All right. So now we're going to just reheat that solder, which will be difficult now that we have more thermal mass trying to suck up all that heat. And also I'm trying to do this backwards and on camera. And once that solder, whoops, that will happen a lot with surface mount components. All right, that's good. Up. And once that solder underneath melts, it's really going to glue this on, and then we can add a little bit of extra solder too. A thinner needle-like tip would also help. Here's what I'm going to do. I'm going to add a little more solder. And I'm just going to, while it's still molten, I'm just going to slide this on. All right, there we go. Not perfectly aligned, but definitely good enough. And once we add a small amount more solder, that will keep it into place. This is not an application that requires a horrendous amount of shock resistance or bumping or vibration. If you're making an off-road synthesizer, you need to consult someone else. Now let's just solder these other pads right here. And if you notice any issues with this, feel free to let me know. I only started learning electronics a couple months ago in earnest. So I'm always looking for new ways to improve. All All right, nice. After you do a solder like this, especially on these surface components, which can be quite small, look in between these pads and make sure you don't have any solder that's bridging the gap between the two. All right, last up, for now, I'll just show one of these little pads. This size is called 0805 for a surface mount component, meaning it is 0.08 and 0.05 of an inch in length and width. Really small. This is kind of the smallest surface mount component I'm able to solder, and many people, but it is not difficult once you have the technique down. So what we're going to be soldering to this pad right here is a 10 microfarad ceramic capacitor. So this tiny little grain of rice, honestly, half a grain of rice. I can't even get the camera to focus on that, especially not without burning my fingers. There we go. So we're going to solder this to there. Now this is an unpolarized component, which means that it doesn't matter which way around. Oh, already dropped it. I'll have to know where that is and not lose it. Same thing though, I like to tin one of the pads. And then I will solder this on. The rest of them are going to go just like this. I'm going to hold the iron on, let that melt under it. Ah, good. All right, that's a nice connection. I don't want to mess with it too much though, because only one of those is soldered. And we're going to solder the other pad. You know, I cannot for the life of me find consensus online about what size capacitor you're supposed to use for these linear regulators. Some of them say just one, some of them say two, some of them say you need a polarized, some of them say only unpolarized, 10 microfarads, 1 microfarad, I don't know. The good thing is you can just sort of do what you want, go to flavor that you like. And then once we get the second pad, we're going to come back and just touch up the first pad a little bit. There was already a little solder on the iron, so that looks like a good connection. Yep, that's not going anywhere unless I literally sneeze on it. But yeah, then we're going to do that for the rest of the components that we wish, and that will be the power circuitry. Remember again that you do not want to jump the 0 ohm bypass on the bottom if you want to install this power protection circuitry. The last thing that we can do is install a headphone jack, horizontal or vertical, or a potentiometer here. I'm going to do, let's see here, what do I got handy? I have a 1/8 inch 3.5 millimeter headphone jack that is pretty much the de facto standard in Eurorack. It's a pretty easy fit, but might require just a little bit of pushing and finagling. There we go, nice and flat. All we do is just what you can do to just give it a little extra mechanical edge. You can bend these tabs over before you solder, but I think we'll have more than enough holding power. As always, flux, I cannot believe I thought flux was optional before. It's mandatory in all cases, and boy does it make things easier. I think it's actually magic. What it really does is it draws the solder into the flux, which I know because that's exactly how I do plumbing soldering when I need to, which thankfully is not frequently. All right, we're going to do the same thing. These are bigger pads, and they have a bigger hole, so we're going to maybe need a little bit more solder in that. Actually, that's pretty nice. Might take a moment longer to heat it up. Always solder in a well-ventilated area. In addition to my little fan, I have the door open directly behind me. All right, there we go. Now that is a good electrical connection and also a good physical connection. This is not going anywhere. All right, now whenever I plug in an audio jack into this, it will go out the tip, ring, and sleeve sections of this pin right here, right onto the breadboard. Nice. Well, that just about wraps it up for the Croissant prototyping board. If you want a Croissant of your very own, the design files are all free. You can upload them into any PCB service you want. I actually got 15 of these with tax and shipping for $10. So they're pretty cheap these days. We are living in a golden age of small scale hardware and micro scale hardware. So if you're in any way interested in designing electronics or synthesizers or circuit boards, I have a great tip for you. You can go to the dermatologist and ask them to look at all the moles on your skin. That's why I have this Band-Aid on my neck. See you next time.